Imagine a night sky, a million stars shimmering above, each one holding secrets that span billions of years. Even the most powerful ground-based telescopes can only reveal a fraction of those secrets, limited by our atmosphere, by the very air we breathe. Now, imagine breaking free from that atmospheric veil that softens and dims the light from the cosmos. Picture positioning a telescope outside those limitations, where nothing stands in the way. No clouds, no light pollution, no atmosphere. What you would witness would be beyond anything humanity has ever seen with the naked eye. Space telescopes. These engineering marvels have opened new windows into the cosmos, revealing things we could only dream of, from the edge of our solar system to the furthest reaches of the universe. These telescopes have transformed the way we understand our place in the vastness of space. You might ask, why send telescopes to space? So far from home when we have thousands of observatories right here on Earth? The answer lies in our atmosphere. While it protects us from harmful radiation, it also blocks crucial parts of the electromagnetic spectrum, in other words, light. From visible light to infrared, ultraviolet, X-rays, and gamma rays, these wavelengths hold clues to the most powerful and distant phenomena in the universe. But from Earth, we can only observe a fraction of them. By launching telescopes into space, we can observe the full spectrum of light. We can see the birth of stars, the formation of planets, and even look back in time, witnessing galaxies as they were billions of years ago. In 1990, a space shuttle carried a revolutionary instrument into orbit, the Hubble Space Telescope. It was a new beginning in space exploration, a floating eye that could see further than anything before. But Hubble's early days were far from perfect. When the first images came back, they were blurry. A flaw in the mirror had caused a slight imperfection, a misalignment so small it was barely noticeable, but enough to ruin the focus of its observations. NASA didn't give up. In 1993, astronauts performed an extraordinary spacewalk to repair Hubble, installing corrective optics. With Hubble's corrected vision, we were given images that changed our understanding of the cosmos. The famous Deep Field image, a snapshot of a tiny, seemingly empty patch of sky, revealed thousands of galaxies, each one containing billions of stars. Hubble didn't just show us the universe as it is. It showed us what it was, how it has evolved over the billions of years. The distance of the light captured by Hubble allowed us to look back the furthest in time than ever before. It's one thing to theorize about the Big Bang and the expansion of the universe, but to actually see the evidence of it happening was a leap beyond imagination. While Hubble revolutionized our view of the universe in the spectrum of visible light, there's much more to the universe than what the human eye can see. The James Webb Telescope, set to launch nearly 3 decades after Hubble, is designed to see in infrared, revealing things hidden from even Hubble's sharp vision. Why infrared? Stars and planets form inside massive clouds of gas and dust. During this process, all sorts of light is emitted, but visible light simply can't penetrate these clouds all the way to us. Infrared light, on the other hand, has such a small wavelength that it cuts right through the density of those clouds, allowing us to see the very beginnings of star and planet formation. The James Webb has taken and will take us even further back in time than Hubble, capturing the faintest glimmers of the first stars that formed just after the Big Bang. But infrared isn't the only invisible light we're interested in. X-ray telescopes like NASA's Chandra X-ray Observatory let us peer into some of the universe's most energetic and extreme events. With X-rays, we can observe the violent deaths of stars, supernovas exploding with unimaginable power. We can see black holes devouring entire stars, their immense gravity pulling everything in, creating jets of X-ray radiation that stretch across light years. Space telescopes don't just look at distant galaxies and nebulas. They've also become our most powerful tools for exploring planets beyond our solar system, known as exoplanets. Over the last few decades, missions like Kepler have identified thousands of exoplanets, some of which lie in the habitable zone, the region around a star where conditions might be right for life. But identifying a planet is just the first step. Now, with instruments like the James Webb Telescope, we'll be able to study the atmospheres of these distant worlds. What's in the air? Could they have water, oxygen, or methane? The chemical fingerprints of life? Imagine the moment we find undeniable proof of life on another planet. The impact of that discovery would ripple through science, philosophy, and humanity itself. It would be one of the most profound moments in our history. And we're not stopping there. The next generation of space telescopes, like the Nancy Grace Roman Space Telescope, will take the hunt for exoplanets even further. Roman will be able to detect planets thousands of times smaller and fainter than anything we've seen before. But it's not just about planets. These future telescopes will also search for the mysteries of dark matter and dark energy. We are standing at the edge of a new era of exploration. With every telescope we launch, we take another step closer to answering some of the universe's deepest questions. No matter how far it is still, we take another step closer. Space telescopes are more than just instruments of science, they're time machines. They let us look back billions of years to the birth of stars, galaxies, and planets. They let us peer into the very fabric of space-time itself, seeking answers to questions humanity has asked since the dawn of civilization. Are we alone in the universe? How did the universe begin? And what is its ultimate fate? As we gaze up at the night sky, it's humbling to know that far above, these incredible instruments are working day and night, revealing the secrets of the stars. And who knows, one of these discoveries might just change everything.